But he does have a process named after him, so he must be a pretty important guy. All right, so here we go. Here's how it works. Pay attention now. Here's the system. And we're going to solve it using Cramer's rule. So the first thing I want you to do is make a determinant of the coefficients. So by coefficients, I mean 2, 3, 3, negative 4. Now, when I say make a determinant, you know how to evaluate that. How do we do this determinant? This will be on your quiz tomorrow. Doing a determinant. Not doing Cramer's rule, but doing a determinant. How do we do this determinant? What do? We multiply these two, and we get negative 8. And we multiply those two, and we get 9. And we always subtract them. When we do a determinant, it's this. And remember, you always start with the very first number. So it's this minus this. So I got negative 17. Now, when I'm solving a system, remember, I am looking for an x and a y. Just like when you did substitution, you're looking for an x and a y. That negative 17 is the denominator for x and y. So we're going to find x and y in pieces. The first thing we do is find their denominator. That's just the determinant of these coefficients. Okay, still with me? Now, to find the x numerator, it is another determinant. But this determinant will be 1, 2, 3, negative 4. Now, how did I do that? Well, these are the x numbers, right? These were the x numbers right here, and these were the y numbers right here. When I am finding the x numerator, I take out the x's and replace them with the constants. These are called the constants. They don't have any letters attached to them. So I simply take the 1 and the 2 and paste them right on here. So that becomes my new determinant. Okay, so everybody see what I did? I took the 1 and the 2 and pasted them on top of the x numbers because I'm solving for x. Now, what's this determinant? Negative 4 minus 6, it's negative 10. That's the numerator for your x. Now, what do you think? Do you have an idea about what the numerator for your y might be? I leave the 2 and the 3, but that's right. I take these and glue them on here, because when I'm finding the y's, I cut this out and paste it on top of the y's. Okay, so when I'm looking for y, I cut out my constants and I paste them on top of the y numbers. So what's the value of this determinant? 4 minus 3, which is 1. So that becomes the numerator of my y. Yep. So Colleen says, can we just go ahead and get rid of those negatives? And yes, we should do that. We absolutely should do that. And there's your answer. Now, some of you are thinking, I just want to substitute or eliminate. Well, you know what? Substitution and elimination is hard when you get answers like this. Because remember, once you figure out what x is, what do you have to do? Plug it back in. And when you have an ugly number like that, that gets hard to do. Here, I got fractions as my answers, but I never really had to deal with the fractions. So Cramer's rule can be real handy sometimes. All right, let's try another one. Let's try the next one. See how you do with that. All right, so x plus y. All right, who remembers how we start?
You do one, or you have to make the determinant.
Have to make the determinant of just the coefficients. So 1, 1, 2, negative 1. So I got to figure that out. So that would be negative 1 minus 2, which is negative 3. Now, what's the negative 3?
The denominator.
It's the denominator for both of your answers. X and y are going to be fractions, and they're both going to be over negative 3. All right, so now we have to find the numerators. And that means 2 more determinants. Remember, when you built the original, this was the x numbers, and this was the y numbers, right? So we're going to take these right here, and we're going to paste them first on the x's, and then on the y's. Does that make sense to you? See what I'm doing? All right, so what is this determinant? Negative 7 minus 8, negative 15. That's my x, numerator. And 8 minus 14, negative 6. So this time, what did our answer simplify to be? Last time all we could do was cancel out some negatives. This time we can really simplify. It's 5, comma, 2. 6 over 3. 5, comma. Now, could you do this problem with substitution or elimination? Yes. That's not the point. The point is we're giving you another tool, another method to do it if you want to. All right, do you feel like you can do the next one on your own, or should we do one more together? On our own? All right, let's go. Do it on your own. See if you can get C. I will do it up here at the board, but try not to look up here. Do C, compare with your neighbor if you get stuck. Anybody matching my answer? I got 13/5, negative 3/10. Anybody have a question about something I did? Morgan, you okay? Got it? All right, there's one more. Do I have a volunteer to come up and do it at the board? Who's gonna volunteer? Gabby, all right. Everybody else at your seats, please. Gabby, why don't you these black markers work better? I did not get enough sleep last weekend, and I still have low blood counts. Not terribly well. I mean, I'm fine, but I'm a little immune depressed. There's a lot of bugs going around, and I just got run down. All right, you're all supposed to be working on this right along with Gabby so that you can see if you get the same answer she does. Okay, she got negative 55/23 and 19/23. Anybody have an issue or a question about that? We're all good? Okay, here's what we're going to do now then. We're going to do a little practice for our quiz. So everybody's got Cramer's rule down.
Yeah.
Okay, you got some Cramer's rule homework to do. Last night's homework was all on the calculator. This is Cramer's rule. You need to keep, get busy on all this stuff because we only have one more section to cover, and then all the homework's going to be due. So it'll be due relatively soon. Okay, so get on top of it if you haven't started it yet. Now get out a clean sheet of paper, and we're going to do a little matrix practice. We're going to go to last lunch today. I have to observe a classroom.
Yes, I like last one. Can I have a piece of paper? I don't have any paper. I have no idea.
Okay, so we're getting out a sheet of paper.
Isn't that 11:15? Oh, it's 11:38 right now. No, 12. I'm elaborated.
All right. So across the top of the paper, these are the matrices we're going to use on our little practice quiz. This is our practice quiz. Okay? So you can expect the real quiz that you get tomorrow to have some matrices across the top, just like this. And then all of the questions are going to use these matrices. Okay? So write those down across the top of your paper. Now I'm just going to start asking questions and you're going to start answering them. So tomorrow, across the top of the paper, we're going to have all these matrices, and we're going to have some questions. So here's number 1. All right, see if you remember how to answer that. You forget how to do it, so see what he's doing? He forgets how to do it, so he's looking back at his notes. That's what we do. That's how we remember. This is a pretend quiz, so we're allowed to look back at our notes. Tomorrow, you won't be able to look at your notes. You remember how to do it? Who remembers how to do it? We add these two, 0. We add these two, 6. These two, 3. These two, 9. There you go. There's your answer. That's how we add matrices. Now, what if I said, let's add A and C?
Can't do it.
Can't do it. So you can put an empty set symbol, you can write can't do, or you could explain to me, Mrs. Ford, they have to have the same dimensions in order to add them. They have to be the same size. Remember that? All right, so what about this question? What's that, Morgan?
Do you add them, like when you do it row by column, do you add them together or subtract them?
What do you mean?
Like 1 and 2 and then -1 and 0, you know how you multiply them together?
Okay, no. When I am adding matrices, this is an addition problem. When I am adding, I add this number and this number. I add them. Then I add this number and this number. And then this one and this one and so on. When I'm adding, that's what I do. I think you might be getting this mixed up with multiplication, and we're not. I haven't done one of those yet, but we will in a minute. Jonathan?
So if C wasn't like 2 rows, 3 columns, if it was 3 columns, 2 rows, wait, what am I trying to say? If it was the other way around, you would do it, right?
No. When you are adding, they have to be exactly the same size. Because the adding process, Jonathan, is this spot plus this spot.
Yeah.
This spot plus this spot. If they don't have the same spots, you can't do it. Okay? Now that's the rule for addition. You've got to keep that straight. You guys are starting to mix up your multiplication. For addition, they have to match up perfectly so that you can add them. Okay? All right. All right, now I'm ready for number 3. Have we figured out what we're doing in number 3? We're going to take every number in the matrix and we're going to times it by 2. So that would be 2, 4, -6, 2, 10, 0. Everybody okay with that? Now, what if I said, so we know what A is, and now we're going to subtract 2 B's. So 2 B's would be -2, 8, 0, 10. You in agreement? No, that's not the answer. Now I'm going to actually get the answer. It's like a 2-step problem. Because first I had to do this by 2. Now I can do the subtraction. And I'm subtracting. So 1 minus -2. 3. 2 minus 8. 3 minus 0. 4 minus 10. a lot to keep track of if you don't, so. Emily?
Why wouldn't you distribute the negative? Like, or do you just multiply by 2?
And then subtract. If you can distribute the negative, but then you turn it into an addition problem. So you gotta make sure you're adding and not doing a double subtraction. So I always just, alright, figure out what 2b is, and then subtract 2b, yeah. Alright, next problem. Now we're going to multiply. This is what some of you were thinking about earlier. So we are going to multiply matrix A times matrix C.
C 2 by 3.
That's a great question. I can put that question on the quiz too. Let's go ahead. What is this, question 5? Let's just say question 6 is what are the dimensions of A, C, and D. So let's do that one first. What are the dimensions of A? Dimensions are rows by columns.
2 by 2.
So A is a 2 by 2. C,
3 by 3.
rows by columns. Remember, rows of the bleacher, columns of the White House. So it's 2 by 3. And what are the dimensions of D? 3 by 3. Now you really need to know that, some of that anyway, in order to do the multiplication. This is a 2 by 2 and this is a 2 by 3. And what's the rule for multiplication? These have to match up. Now, the rule for addition is this has to be exactly the same as this. But in multiplication, we just got to match those middle ones. And our answer will be 2 by 3. Okay? So now we're going to fill in all of these blanks. Is everybody okay to this point? Right, so we're going to fill in this first blank right here, which is row 1, column 1. So row 1, column 1. So I take the numbers in row 1 and write them down, spread them out. Then I take the numbers in column 1 and write them right next to there. And then I add those up. Morgan, is this what you were asking about maybe?
Yeah.
So that first number would be a 3. Now, if I go to this spot next, and order doesn't matter, so go anywhere you want, but if I just stay organized and say I'm going to this spot next, that's row 1, column 2. So I'm going to multiply my row 1 numbers, I spread them out, times my column 2 numbers. So that number would be a 12. Now I'll take my row 1 numbers times my column 3 numbers. So that would be -3. There's a lot to keep track of. Are you keeping track of it all? You got the bottom row done? I know some of you are working ahead. What's the bottom row?
726 -9.
Can I believe Jonathan? Now we're going to take a minute Those of you that can't get 7, 26, and negative 9, let's talk about it. Which of those numbers is bothering you a little bit? Let's just do this one together, just to make sure everybody can get it. Where is that? That is in row 2, column 2. So I'm going to write down my row 2 numbers, 3 and 4, and my column 2 numbers, 2 and 5. And sure enough, that makes 26. Trey, what's the matter? Did you not match any of those, or?
Yeah. I matched the first.
Okay. All right, well, watch carefully. We'll do this one. I'll do this one. All right. So that spot, you got to pay attention to what spot that is. That spot is in the second row, third column. So I'm going to multiply the second row, so there's 3 and 4, spread them out, times the third column. So I get negative 9 plus 0, which is negative 9. Okay? If we have time, we'll do one more matrix multiplication, but I want to get the rest of the quiz here. Okay, so that was 6. All right, here's question 7. And this will be easy after what we practiced today. What does that mean? Find the determinant of B. So B is the matrix negative 1, 4, 0, 5. So how do we do a determinant? We just practice it with Cramer's rule. Negative 5 minus 0. So that determinant would be negative 5. Now question 8 is going to be the same thing, but it's going to be a little bit bigger. Because question 8, I'm going to ask you to find the determinant of D. Right, this is kind of the same, but kind of different. So what do? Take the first 2 columns and write them out here. Everybody remember that step? Now, do you remember what to do next? Start and write. We start with the very first number we wrote. So we start right here and we multiply. We multiply. So we get 12. And then we multiply again. And we get 0. And we multiply one more time and we get 2. Positive 2. Yep, so I add these up so I get my total. So my total of this multiply, multiply, multiply is 14. Now I go back the other way. So I multiply 4, and again, and one more time. And I total those up and I get 4. I subtract those 2 numbers. 14 minus 4, so the answer is 10. Is that okay? All right, one more question. So the quiz is going to have something around 9 questions here. Find this. Now, what does that mean? What am I looking for? the inverse of A. This means find the inverse of matrix A. Does anyone remember how to do that? Jonathan?
You just flip the 1 and the 4.
Okay, so I need to build a new matrix. So I need to build a new matrix. And to build the new matrix, being A, I take these two numbers and flip them, remember? So the 4 goes here and the 1 goes here. Perfect. Then what? These guys are both positive, so they're going to become both negative. You leave them where they are, but you change their sign. So since they're positive, I make them negative. If they were negative, I would make them positive. We're only half done.
Wouldn't that give you the same thing anyway? Like if they're both negative, your answer's still going to be positive. If they're both positive, your answer's still going to be positive.
What do you mean? When you find their determinants or something?
When you flip the other two signs, like when you put a negative on 2 and the 3, you're still going to get the same answer as you would have with regular.
When you multiply them, you mean? Yeah, you're exactly right. This is a 2-step problem, and we've only done 1 step. Does anybody remember what the other step is? You gotta multiply this by 1 over the determinant. Remember when you do inverses, you almost always get fractions? And the reason you get fractions is because you're multiplying by 1 over the determinant. What is our determinant here? -2. So we're going to multiply this by 1 over -2. 1 over -2. So what is -1/2 times 4? -2. What is -1/2 times -2? +1. -1/2 times -3. 3 halves, or if you want to write 1 1/2, you can. And -1/2 times 1 is, of course, -1/2. That is your final answer. Okay? Now, wait. We still have time, so I don't want to pack up. I want you all to find B inverse for me. See if you can find B inverse, the inverse of B. You're going to have to do this on your quiz tomorrow, so let's use this time to practice. Hopefully get good at it. Joseph, you can't do this in your head, sweetie. Even you. Gotta put it on the paper. So it's a 2-step process, right? So remember the 2 steps. Yep. But actually, as Jonathan pointed out, the inverse of the original and the inverse of the new matrix will actually be the same always. So if you get confused, it won't matter. But yeah, normally you just do the original. Oh, is it your reminder? Oh, okay, that's allowed.
Phone was out.
Yes, it is in here. All right, so you got a determinant of negative 5, so we have negative 1/5. What's this new matrix look like? What's here?
Negative 1.
No. What's here?
Positive 1. 5.
This is 5, this is negative 1. Kids, remember, you gotta switch these.
Yeah.
And then we change the sign on those. 0 say 0. So your answer should be negative 1, 4/5, 0, and 1/5. Did anybody get that? All right. Are we ready for a quiz tomorrow then? Everybody's clear on this? All right, I would suggest, we still got a little bit of time, but I'm gonna let you go ahead and get some homework done. Because tomorrow we start linear programming.